variable. So first, let's have this scenario. Okay, we have a manager of a medical clinic in Arizona. He wants to analyze patients' data to identify high-risk patients for cardio disease. From the literature, he learned that the risk of cardio diseases is influenced by a patient's age, BMI, amount of exercise, race, and education level. Jerry has compiled the data file with the following variables for his clinic's patients. He's got the race, he's got the education level, he's got the body weight in kilograms, and the height in meters, date of birth, and number of minutes of exercises per week. Okay, so in this question we are going to go over some transformation techniques for numerical variables. Okay, so before we start answering questions, first what we have to do is, again, loading the library, importing the datasets. So first, let's import the datasets. The library is read Excel. Again, we are still working on project chapter 2, our working directory. Just to make sure that you are working on this project, you can set as a working directory, which is, by default. Then we are going to call our data, my data. So read Excel as X, chapter 2 dot, for the sheet is going to be patients. Then run the code. Then view our data. We have 400 observations. We have 6 variables. We have race, education, weight, height, birth date, exercise. So we have 6 variables. It's clear that some of them are numeric, some of them are characters. But let's explore this. Explore the data sets. Let's look at the structure of the data, and we can view the first few or the last few observations using head function or using tail function, or you can use the summary function. So to do this, let's look at the structure of the data. So what we have, the race and education are character, the weight and the height are numeric, the exercise is numeric, and the birth date is a strange format. We're not familiar with this. Remember, birth date has to be in a date format. So we'll be talking about this. So let's leave this for now, but we will come to this point. At least we know that this is the structure that how R reads the dates, okay? The birth date here. Now let's go to A and try to answer the first part. Again, this is part of data management techniques, so data transformation. Chapter 2 is all about preparing your data, inspect your data, and make your data ready for the analysis. So that's why these functions that we are using here in chapter 2 are very important for you to practice, because these will be used regularly in subsequent chapters, chapter 8, 9, 10, 11, and so on. So first part here says, create a new variable called BMI that contains the body mass index of the patients. BMI is calculated as a weight in kilograms divided by the height in meters squared. Then the question says, what is the average BMI of the patients? So we have 2 parts here. The first part, we have to create a new variable, which is called BMI, for each patient. After that, we are going to calculate the average of the BMI. So I'm going to call this part BMI variable, okay? The idea is adding a BMI. So this is a calculated field. So this is a calculated variable. This is mathematical transformation. We are going to use 2 variables to create a new variable. It's a mathematical equation simply. But I would like to add this variable to be on this table, because we would like to have the BMI as a variable for each patient. So I would like to calculate the BMI for the first observation, the first patient. the second patient, third, and so on. So that's why we have to add another column. In this case, what we do, because I'm going to add this new column to my data frame, which is my data frame is my data, we add $sign, then you add a new name for that column. In this case, I'm gonna call it BMI. So what does this mean? It means that in your data frame, you are going to add a new column called BMI. Then you are going to put some data on this BMI. What kind of data you are going to have? Now we are gonna do it. I'm going to have my data weight. I'm going to divide the weight by the height squared, simply. I can't say this. I can't say weight divided by height. I can't say weight divided by height squared. This is not gonna work in this sense. We'll be learning something in the future how to make this work, but now, because what is weight? R doesn't understand what is weight. R understands that the weight is a column in my data. So this is the weight. This comes in my data, which is a data frame. So this is incorrect, so I'm going to delete this. So after you are getting this, you are going to run this one. After run this one, you can go to my data, look at the BMI. So we create a new column, BMI, by dividing the weight by the height squared. We are lucky because this is in kilograms already and this is in meter already, so there is no need to do any conversion here. If we need to do any conversion, we have to make sure that we do the conversion mathematically, just mathematical operations. So now we create a new variable. It's a good idea to look at the structure, by the way, or to look at the structure again, or you can look at the class, by the way. If you use a function called the class, you can look at the type of this new variable that we created. So the BMI is numeric, and if you don't want to look at the structure for the whole thing, you can just choose the class. Look at the class, it says numeric. So the BMI is a numeric function, is a numeric variable, sorry. The question is how to find the average. Now let's find the average. To find the average, we are going to use the mean, right? We are going to use the mean. So the mean of my data, BMI. So I'm going to find the mean, but I would like, again, as we did before, do not count the missing values. Remove the missing values. So this will give me the mean. If you'd like to put this in a good reporting context, you can add the concatenate function, cat function. You can say the average BMI is equal to, comma, the average is what? Is all the whole thing, this guy. Either you copy this one, you put it here. Let me put it here as is. Comma, if you like to go to a new line, /n means comma, look, comma, new line. So that means once you do this, do a new line. So there is no need to see this line. I can delete this line because already I can see it here. So I can delete it from here, right? So this is the average. Good. Let's go to part B. In part B, we have to create a new variable called age that contains the patient's age as of January 1st, 2022. Then the question says, what is the average age of the patients? Okay. So now the idea is creating a new variable called age. And the age, to get the age, we have to simply, mathematically speaking, we subtract the birth date from the January 1st, 2022 number of days. We calculate number of days between these two numbers, right? So the birth dates, right? So the birth date and January 1st, 2022, we subtract them, we get the age in days. Then we divide this by 365 or 365.25 because we have a leap year, right? Then we get the age in years, right? So this is exactly what we are going to do, but we have some technical stuff we have first to check. The first thing we have to do, we have to fix the data type of the birth date, because if you remember, we have this strange date type, right? Because this one gives you the date in seconds, and we don't want this format, so we have to do something first. So the first thing we are going to do, we're going to change the type of this. So we are going to change the data type to date, and we do have this in R. So number one, let me first say here, let me call it create the age variable, right? The subheading here, variable, age variable. Then now we are going to say what here? We are going to say convert birth date variable into date values. And how are we going to do this? By simply convert the same column, birth date. I'm going to change the values in this column, which is birth date. I'm going to replace these values with the same values but with different format. This format is going to be called as date function, as date. So keep the same values. So I'm going to say, look, I'm going just to put the same values. So keep the same values but change them as date. The format is going to be date. And I would like to use the American system format, which is format. What is the format? Format is another argument for this function. Format. It's going to be like this, and this is a standard way of writing the format. Between double quotations, %, M stands for month, slash, then day, slash, then year in caps letter. So this will keep that format stored in the system. So if you run this now and look at the class now, let's look at the class of my data birth date. The class is date. Or if you like to view the structure, all of them, there's no need by the way, but my data birth, no, my data, that's it. It's date. Okay, let me delete this. I don't need it. So the class is date now. Okay, after we have the birth date converted to date, we would like to create a new variable called end date. And I would like to have the same format because look, the idea is, as I said, we would like to find the difference between two times, right? To find the difference, we have to have the date, birth date. We have the birth date, which is this. Then we're going to subtract this from January 1st, 2022 or 2020. Yeah, 2022. So before we subtract, let's create that date. So let me type it here. Create a new variable for the January. Just variable contains January 1st, 2022, right? Because we want to find the difference between the two dates. But the question is, it's a good question to ask. Is it necessary to add this new variable to the column, to a new column here? Like to have January 1st, 2022, January 1st, 2022, January 1st. Do we have to do this? Do we need to do this? Or is there a need to do this? There is no need to do this because every time you're going to subtract this number from the same number. So there's no need to create a new variable that contains one value, right? So there is no need to add the end date to the table or to the data frame. That's why I'm going to do what? I'm going to just call it end date. This variable that I'm going to create is just nothing. It has a date format. It's going to have this format. Same thing, $sign or %sign, capital letter Y. Month is small, day is small, year is capital. Now we create end date that contains one value only one value. And again, remember, they have the same format, because when I subtract them, we get number of days. Run. So look at this. We have end date. It's not part of the data frame. It's something, it's just a variable. A variable has a value of January 1st, 2022. That's it. It has one value. It's not a data frame. It's not a column even, right? After that, we're going to find the difference. So find the difference between the two dates. To find the difference, you're going to get number of days, because you have the birth date and January 1st, 2022. If you subtract them, you're going to get number of days. And we're going to use a function called diff time, right? So because I'm going to find the difference, I'm going to get number of days, or your age, or the patient's age in days, but I will divide this by 365.25 because of the leap year. So in this case, we are going to get the age in years, okay? So diff time is a function will be used to find the difference between what and what. End date first, then my data birth date. So subtract these two numbers. Remember, the first one is the latest and the second one is the earlier. After you find the diff time, again, diff time gives you what? Diff time give you number of days between both days, both dates. After you're getting number of days, so we got the age in days, we divide by 365.25. So this is going to be the age of the patient, each patient. So that's why we are going to add this piece of information to my data frame, because I'm going to add a column called age, because this is the question. The question says add age. We create a new variable called age. So I'm going to add, so my data age. So we added a new variable called age. What we are going to put in this column, yes, the difference between the two dates divided by 365.25. In this case, we're going to get the age in years. Let's run this and see. Let's go and look. So we got this. So we have problems here. We have many problems. The first problem is we have decimal, and the age normally here in the States we don't record this. We just floor the age. For example, this guy is 36.8, his age 36 years, 0.8. We don't do this. We say he is 36. Until he hits the 37, we say 37. So any number has a fraction, we have to take off the fractions. Okay? So you have to take off all of the fractions. To take off the fractions, to take off all of the decimal, we use a function called the floor. So this is easy to use the function called floor. Also, we have another problem that we don't know the structure of this. So let's look at the structure of this. Let's look at the class of my data age. So the class give you diff time, so a difference between time. So the class is in days, so that's why we have days here. But we don't want to have this in days. We would like to have this as an integer. Okay, so to fix the problems, we are going to add floor variable. So next, after getting the age, we're going to fix it now. So to fix data type problem, we use as integer function. To fix the decimal part, we use what? Floor function. So I'm going to replace my current age function, my current age column, sorry, not function. So I'm going to replace the column that contains age with the same values. I'm not going to change the values, but I'm going to do some changes in the types. So I'm going to make it floor first. I'm going to keep the same values, age. I'm going to keep the same values, but make it floor. Take off the decimals. At the same time, after doing this, I'm going to make them integer. So I'm going to add integer as integer. By the way, to change from data type to data type, we have as date. Do you remember as date? here as integer, and we used before as factor, and we use another thing as numeric. So change it as numeric. So again, what's happening here? My data $sign age. So we go to the column of the age. We say, okay, go to that column, take each value of that column, make it floor, delete all of the decimal values. After that, change the format to be integer. Let me run this. Let me run this again. The class becomes integer. Let's go here, close it, open it. Look at the age, 36, 58, 61, 20. In R, the codes are run in order. So if you run something here, you're going to see the impact. If you go back and run this again, the impact of this one is going to be gone. So if you try, for example, to do this again, this one, if you run this code chunk, so let's run this one alone. Command, enter. Let me go to my data. We got back to the original look. Run this line again. We got the new age. So every time you want to do some changes, you have to run everything. Okay. So if you want to change something here, that's fine, but you make sure that you run this and this before you jump into the next step. So we created a new variable called age that contains what? The patient's ages as of January 1st, 2022. And this is an important function. These are important processes here, by the way. It's very common to do this. Then next question says, find the average age. We have done this many times. To find the average, we use the function mean. Find the average of age. So we use the function mean, my data, age. Again, don't calculate what. You know what I'm going to say. So the order is important. For example, if you take this copy, if you copy it and you throw it here in line 65, you're going to have a problem. Why is that? Because you still have the age in that format, or here in 69, then you change the order, then you change the type of the age. No, this is not going to work. First we change the type of the age, then we find the mean. So run this. So what's the average? So the mean number of the patients is 45.29 years old. Let's go to part C now. So part B, we're done. For C, we have to do some binning now. And this is important again, categorizing. So binning what we are going to bin, ages. And yes, as we said, when we do binning, we are going to categorize the ages. We are going to create categories for the ages because we have maybe a wide range of ages. So in this case, we are going to create groups. And you've got to remember this. The question says, the question is very specific here. It says bin the patient's ages into 5 equal size groups. 5 equal size groups. After binning, it says label the groups using numbers. 1 is youngest, 5 is oldest. Then the question says how many patients are in group 4. Okay, we have many things here. Normally, when you are asked to do binning, and in this example, the question asks you to create groups or categories, and he says 5 equal sized groups. Remember that we are going to use 2 functions. So let me write this down here. When binning, we normally use 2 functions. The first one, I'm going to call it quantile, and the second one is cut. Quantile, what does a quantile do? It gives you the 5 equal size groups, the cutoff for each group. Okay, so let's use quantile first by creating, let's call them the bins, or the age bins. Quantile. I'm going to ask R to go to the age column. So my data age, oops, I forgot to have a chunk, right? So age bins, quantile, go to the age, and I would like you to create cutoffs, the second argument of the quantile. In the quantile, we are going to use two arguments. Again, how to check the arguments? You can use RGS quantile. So it's a function, or you can, by the way, you can use a question mark. Quantile, quantiles. We have many arguments. Quantile, the first argument is the vector. The second argument is how you would like to divide your data to create the bins. Second one, do you want to create the, do you want to have the, how do you call it? The NA, the missing values to be included, the default is false. So we have so many arguments, there's no need to look at all of these arguments. We're going to focus only on the first two. So we're going to have only two arguments. The first one is I'm going to ask you R to go to my data age, go to age, then props, sequence, create a sequence from 0 to 1. This is always from 0 to 1, from 0 to 100%. Then I'm going to do it by what? You either write by or just without by. Okay, how many groups that we are going to create? We said 5 groups, because 5 groups is going to be every 20%. So 0.20%. From 0 to 20%, from 20% to 40, from 40 to 60, 60 to 80, 80 to 100. If it says 10 groups, then you have to do 10%, and so on. Okay? Let's see, what does this mean? What does this give you? The quantile function. Let's run this. Okay, I run this. You see nothing. You see them here, by the way. Age bins. Also, if you'd like to see them down there, you can just type age bins. Look at them. These are the bins. These are the cutoff. These are the cutoff values. So the first group is going to contain ages between 19 and 29. Second group is going to contain ages between 29 and 39.6. Third group between these two numbers. Fourth group and fifth group. That's it. So after doing this, we are going to create or to classify them now. Now we know the bins. Now we are going to go to my data, and I'm going to add another column called age group. Age group. So I'm going to add a new column to my data, which is age group. Again, I said for the binning we are using two functions. The first one is the quantile. The second one is the cut, right? So cut is a bit problematic, but bear with me. Cut. What are you looking for? Which variable that you're going to classify, to categorize my data? Age. I would like you to go to my data age. Okay. After that, we're gonna do something called the breaks. We have many arguments here. Okay. Breaks. Breaks do what? Breaks. It's from the the name of the breaks. Is the break points? Is the intervals for the creating the bins. What are the breaks that you want me to specify the ages? What are the break points? What are the intervals you would like me to use? Is the one we created, is the age bins. So I'm going to copy this age bins. So my breaks are going to be my age bins. So what does this mean? Go to the age column, look at these breaks, and classify the age, each one based on this breaks. We did not finish yet. Not only this, I would like you to give them labels. Label them. How you're going to label them? The lowest one is going to take a value of 1. Second one is going to take a value of 2. Third one is going to take a value of 3, 4, then 5. So after grouping them, just give them labels. Not only this, again, give me labels for the resulting bins. After this, we're going to add something called include. Let me enter. I'm going to hit enter. We have a comma, remember. Include dot lowest. So I'm going to keep this as true. What does this mean? The leftmost interval is going to be closed. What does this mean? The lowest value in the age variable will be included in the first bin. Okay? Another argument called right, and right is going to be true, which is going to be the intervals are closed on the right side. So it's closed from the left side. The lowest one, the lowest value in the age, will be included in the first bin because I used include lowest, and because I said right is true, that means the intervals are closed on the right side. The idea is I would like to include every single value, so that's why I keep these both to be true. Okay, now if you hit run and go to my data, look at the age group. So the first observation belongs to the second age group. This one belongs to the fourth age group. This is fourth age group. This is first age group. So we classified them, we put them in age groups. And these are the intervals. Where are the intervals? We ran them already before. Yeah, the age bins. Between this and this, first group, this is the second group, number 2. The third group, number 3, number 4, number 5. So the first observation, look at the first observation, he's 36. 36, let's look at 36. 36 between these two numbers, he's in age group 2, right? So this is the cut function. This is the cut function. Okay, next what we say, so first let me just write some specifics here. Create bins or intervals or breakpoints. Okay, after that categorize age. Okay, variable, variable, I don't know, variable. Okay, so the question says then, by the way, let's look at the structure of the class of this new variable, which is age group. Not found. Yeah, why? Because my data, here we go, it's factor, which is, yes, correct, character. It's a text, it's factor, right? So now the question says, because this is factor, we would like to know how many patients are in group 4. So now you need to count. And if you remember, this is from previous videos. And if you remember, we used two functions here, the length and which age group. We need to count the ones equal 4. So the which function give me the cases that belongs to 4th age group, and the length give me how many they are. So you have 80. So you can say cat function, you can say number of patients in group 4 is comma, either you copy this or you give it a name. So let's call it a group 4. So I'm going to call it group 4. Then that's it. Oops, I have to run this. Then I run this. Here we go. Is 80. Right? Let's move to D now. Oh, we have so many questions. And we are 45 minutes. Okay, it's going to be a long class. So we're going to kind of repeat the same thing. So in the D and E, we're going to repeat. That's okay. We're gonna repeat. This is nice because we're gonna use these functions. I mean, in your practice, you're gonna use these a lot. So bin the patient's total minutes of exercise per week into 5 equal size groups. Again, 5 groups. Label the groups using number 1, highest value. 1 is gonna be the highest value, 5 is gonna be the lowest value. So we're gonna switch now. How many patients are in group 5? So we're gonna do the same thing. So we're going to do the same thing. We're going to create bins first. Okay. So this is exercise bins. Exercise bins. Using, again, quantile function. And we're going to work with the my data exercise. And we are going to do props sequence from 0 to 1. Divide them into by 20%. Either you type by equals or you keep it like this. Then you can look at exercise bins, then you look at how the minutes are divided into groups, or into intervals or breakpoints. So between 21 minutes to 100 minutes, we have 20% of the data, and 20% of the data between 100 minutes to 119 minutes, and another 20% of the data between 40 to 60, and so on. After that, we create a new function called, so my data, we call it exercise group, right? So we're going to use cut function, my data, exercise. We're going to use the breaks. What breaks we're going to use? The exercise bins are the breaks. And we're going to use, the next one is going to be the labels, right? C, the lowest is going to be 5, then 4, then 3, then 2, then 1, right? After that, be careful because you have parentheses here, comma, include lowest, true, right, also true. I got an error somewhere, so let's look at this. Cut breaks. Let me do enter here. Okay, so we got my data exercise labels C5. This is comma, not dot. Here we go. So let's look at my data again. This is nice. Exercise group added. So we're gonna do the same thing. We're gonna look at the mean of the question. Says how many patients are in group 5. So we're gonna, no, sorry, not the mean. We're gonna look at the length, which my data exercise group, we're gonna count them. So how many? So we have 83. So I'm gonna leave the way of organizing and reporting to you. The last one is bin the patient's BMI into 5 equal size groups. Label the groups using 1 lowest to high, 5 highest value. Then let me copy this. I don't want to spend forever doing this. I'm gonna copy this, carefully paste here. So I'm gonna make sure that this is for BMI, carefully, BMI. I know what I'm doing, but you have to do this manually, so you do not. Okay, nice. After that, this is BMI group, BMI. Then this is age, BMI group. 1 is the lowest. Same thing. After that, I don't want to do the class. So this is BMI group. We're looking for which one belongs to group 1. Again, I'm going to delete this for now. So I'm just repeating BMI. We have a problem. Group, where is it? This has been, sorry. So this has been, here we go. So the length is 80. Good. So we just repeated what we did in the previous parts. It's just the same thing for a different variable called BMI. We grouped the BMI. Look at them. Now we have grouped them. After that, create a risk score. So this is the idea of the whole thing, which is F, getting to the F. So this doctor wants to know the risk factor, the risk score. So part C, we did binning for the age, and here for the exercise, and here we're done the BMI. Finally, we're gonna find the what? The risk score. Create a risk score. Now all of the variables has a factor as a data type, right? As a factor. So in this case, we're going to put these values together into a new variable called risk score. So for example, we're going to put these together because the question says, look, how many patients are in the risk group of 555? So we're going to put these all together by concatenating them. To concatenate values and add them in a new column, we're going to use a function, a very nice function called paste. Okay, called paste. So to concatenate values, concatenate values using paste function. Okay, so I'm going to create a new column called risk score. I'm going only to paste now. Just paste what? My data, age group, comma, paste them, put them next to each other. My data, exercise group, then my data, what? The last one, BMI group. So put them next to each other. So this is going to be my new column. My new column is going to be risk score, and we're going to add all of these values together, not adding. So they're going to be next to each other in a new column. Run this. Look at this. Risk score 242, 433, 423, 135, and so on. And you know the order, by the way. The order is first one belongs to the age, second exercise, third BMI. Then the question says, how many patients are in group 555? This is important because find number of patients have 555 score, which is very high score. Maybe serious problem, right? Serious problem. Again, we're going to use the same function we used before, length, which we're going to go to this column, risk score. If the risk score equals 555, be careful, we have spaces. If you do not put spaces, let's try this. We got 0, but they have spaces. So we have 2 high risk patients. 555, very high risk. Okay, so we need to call them or do something. So this is everything about data transformation for numerical values. We use different techniques. We used binning, and we use mathematical scores, mathematical calculations.